Alright, so today we are going to make a foldable. So you will need to get a sheet of paper out of the folder where it was designated. Now what you're going to do, you're not going to fold it all the way in half hot dog style. Let me zoom out a little bit. What you're going to do is you're going to fold it so there's about a tab, a little bit of a tab hanging out. So fold it that way and then crease it. And then what you're going to do, you're going to take your scissors and you are just going to cut 3 sections. Now clearly mine did not make it even, but that's alright. Okay, so you're going to have 3 sections like that. On the strip, or the tab, whatever you want to call it, you're going to write subatomic particles foldable. On the first flap, you are going to write protons, neutrons on the middle, and then electrons on the last. Alright, so let's just start. Protons. Now, if you remember from the graphic organizer on the atom, protons start with a P, so does positive, so let's just put a little plus sign so we know that protons are positive. If you flip it open, what we're going to say down here, this is just an easier way to read the graphic organizer. So protons are found in the nucleus. They have a positive charge. It is related to the atomic number. And protons identify the element. So on the top, we're going to draw our makeshift nucleus. That's a pretty good circle. And protons are found in the nucleus, so we're just going to put a lot of plus signs because protons are found inside our nucleus. Okay? Now moving on to neutrons. Now in the video I said neutrons sound like neutral, so let's underline this new part because that's what the key is. Neutrons and neutral, that's how I remember it. So they also, let's just say neutral charge. And in parentheses we can say no charge. Neutrons, neutral, no. Alright, so if we open this up, now where are neutrons found? That's right, they are found in the nucleus with the protons. They have a neutral charge. And here's the cool thing. You take the atomic mass minus the number of protons, and that equals the number of neutrons. So again, let's draw another circle. So it's our nucleus. So we know that we have protons in our nucleus. I'm trying to make them look like plus signs and not X's, but can't promise anything. But since we also have protons, we also need to add our neutrons. So just put a bunch of N's. Okay, so we have protons and neutrons inside our nucleus. And now moving on to electrons, electrons have a negative charge, so we're just going to put a big old negative sign. You can put it in parentheses if you like. So if we open up this side, electrons are found outside the nucleus. They are found in an electron shell. You can also say, or layer, either one. I think I use shell more. They have a negative charge. So now what I'm going to draw, you have no idea what this is yet. But I'm going to draw my nucleus. Inside my nucleus, I'm going to say that there are 14 protons. If there's 14 protons, there's got to be 14 neutrons, though. So you'll see in some pictures, there'll be a bunch of circles around the nucleus. These are the electron shells, or the electron layers. And inside those layers are the electrons. Yes, it does matter where you put them. You will learn that eventually. But for now, just copy what I do. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. That's right. Okay. So what else did we say on our foldable? The relationship between electrons and protons. Since I have 14 protons and I have 14 electrons, we can say that the number of electrons equals number of protons. All right, so this is your subatomic particles foldable. Now what you need to do is you need to glue it in your notebook on the next blank page, whatever you have. Then you need to add it to your table of contents. Now it needs to say in your table of contents, subatomic particle foldable.